Okay, hopefully that's working. All right, so we're going to talk about integration. I've just chosen 3 really quick questions. Now, admittedly, I have forgotten my calculator at school, so on that very last question, I won't be able to do entirely, but at least you'll be able to see the methods and that sort of thing. So with this very first question, we've got, given that y to the power of a half equals x to the power of a third plus 3, show that y equals x to the power of 2/3 plus ax to the power of a third plus b, where a and b are constants to be found. Now with this question here, particularly with part A, a classic mistake, what people do is they square each individual term, which is not what you're supposed to do. I want to go from a y to the power of a half, and I want to turn it into a y. And the way I do that is I square it entirely. So whatever I do to the left, I have to do to the whole of the right-hand side. So on the left-hand side, I'm going to have y to the power of a half all squared equals x to the power of a third plus 3 all squared. Now, if I was to square the left-hand side, I just get y, absolutely fine. And if I was to square the right-hand side, what I now get is I get x to the power of a third times x to the power of a third. And then because they've got the same base, you're going to add the powers. So I get x to the power of 2/3, which makes sense because that's my term up here. Perfect. Then I'm going to do x to the power of a third times 3, which is 3x to the power of a third. And then I'm going to double it. So that now gets me 6x to the power of a third. And then I'm going to do 3 squared, which gets me positive 9. Perfect. That's part A. Now, part B, I now need to integrate it. So if I need to integrate it, I'm now going to use this equation here. Okay. Now, the reason for that is in year 12 maths, you can only square it when you've got a y on one side. You can't have it where you've got y squared and blah, blah, blah. You'll find there'll be caveats to that when you get into year 13. But for now, we're just going to have it when it's just y. So I'm going to integrate x to the power of 2/3 plus 6x to the power of a third plus 9 dx, so in respect to x. Whenever we're integrating, you always increase the power by 1, divide by the new power. So if I increase x to the power of 2/3 by 1, I'm basically going to add 3 to the numerator. So it gets me 5/3. And then I'm going to divide by the new power. So in this case, I'm now going to divide by 5/3, which is essentially the same as me timesing it by 3/5. Oh, sorry, my pen went a bit rubbish there. Now I'm going to do exactly the same thing with this next term. So a third plus 1 gets me 4/3. So I'm going to write that down, x to the power of 4/3. Now I'm going to divide by, I'm going to multiply by 3/4. So I can then do 6 times 3, which gets me 18. 18 divided by 4 will just leave me with 9/2 simplified. Now with that 9 there, I can just now turn it into an x, so I get 9x. And then the key thing, always remember the plus c. Okay, pretty standard question there, nothing too arduous. But now you get into this question here. Now this is where you're having to integrate with finite bounds, but it's also raised above the x-axis. So with part A, what we're going to need to do is we need to find the coordinates of A and B. Now A is up here, B is up here, and that tells me that y equals 2. So in my equation, y equals 5 plus 2x minus x squared. If I know it meets at y equals 2, I can just substitute this value here as y. So I'm now going to have 2 equals 5 plus 2x minus x squared, and I'm just going to solve. So I'm going to move everything to the left-hand side. So I'm going to get x squared minus 2x, 2 minus 5 gets me -3, equals 0. I can now factorize. So what I'm going to get is I'm going to get x, because I've got that -3 there, it's a prime number quite luckily, so I can only have 3 and a 1. I can then say I've got x minus 3, x plus 1 equals 0. Therefore, x equals 3 or -1. So at B, it must be this value, which is 3, and then A must be at -1 over here. So now we need to find the shaded region R is bounded by the curve and the line. Find the area of R. A classic mistake, which loads of people make, is when they're doing it, they know they now need to use the bounds of 3 and -1. Yes, that's correct. But what they do is they substitute in the original equation. That's not correct. Now, the reason why it's not correct is because as it's been raised, it's bounded by the line, you now need to use a different equation. And the equation that you can use is now going to be this 3 plus 2x minus x squared, okay? So if you use that one there, then it should be absolutely fine, okay? So 3 plus 2x minus x squared. And the reason why we're doing that is, and you could use either one actually, but I'm now moving this one over here. So I now get 3 plus 2x minus x squared. Now, admittedly, you can use this one as well. I quite like using the original one, only moving one term over. And the reason for that is if I've made a mistake somewhere else, then at least I know that I can pick up some marks still without being a silly sausage. So I'm now going to integrate again each term individually. I'm now going to put it into square brackets, and I'll show you why in a second. So 3 integrated gets me 3x. 2x integrated, I get x squared. 2 divided by 2 gets me 1, so I can just leave it like that. Now then, with the x squared, I'm going to increase the power by 1, which gets me 3, and then divide by the new power, which means I'm basically timesing by a third, or dividing by 3, and I've got that minus in there. I don't need the plus c, because if I've got my bounds, which are 3 and -1, the plus c's will cancel. And what I need to do is I need to substitute my bounds, these ones here, I need to substitute these into the x's individually and subtract them from each other. Now always start with the number on top. So what I'm going to do is I'm going to say 3 squared gets me 9, plus, sorry, 3 times 3 gets me 9, plus 3 squared, which also gets me 9, minus now 3 cubed gets me 27, divided by 3 gets me 9. So I'm going to get minus 9 in there. I'm now going to subtract it, and now I'm going to substitute in the -1. So -1 times 3 gets me -3. -1 squared gets me +1. So I'm going to write down +1 here. Then substituting -1 cubed gets me -1, divided by 3 gets me a third. But then I need to times it by that -1 there, so I get positive a third. So now I'm going to be trying to cancel these out and solve it basically. So these 9s cancel each other out. So I now have 9 minus -3, which gets me 12. 12 minus 1 will get me 11. And then 11 minus a third will therefore get me 10 and 2/3. Okay. Now the very last question is quite a good one actually. So it starts off again really nice and simply. You're just needing to work out the roots here. So the graph shows a sketch part of the graph shows a sketch of part of the curve C with the equation y equals x minus 4 2x plus 3. Now with this one here, what you're going to do for part A, I can tell that my y equals 0 because it's crossing the x-axis. So I can now say 0 equals x minus 4, 2x plus 3. Therefore, x must equal 4, or x equals -3/2. Okay. Now what I'm going to do for part B, and I'll start it over here, is use integration to find the area. So I'm going to set up my integration first. I'm going to integrate it between my bounds of 4 and -3/2. And I should have the equation x minus 4, quadratic, sorry, 2x plus 3 in terms of x dx. And what I need to do, it's impossible to be able to expand it like this, sorry, integrate it like that. So I need to expand it, okay? So if I expand that now, still keep my bounds exactly the same. X times 2x gets me 2x squared. X times 3 gets me 3x. -4 times 2x gets me -8x, and -8x plus 3x gets me -5x. -4 times 3 gets me -12. Okay, so now I can integrate that. Lovely stuff. So 2x integrated gets me x cubed, and then I need to do 2 divided by 3. So I'm just going to write it like that. Minus x is now going to be to the power of 2, increase the power by 1. So I now have 5 over 2, and then I get negative 12x. And then it's within my bounds of 4 and negative 3 over 2. Now, if you were to put this into calculator, and I have to admit I cheated a little bit as I didn't have the calculator, so I just plugged this into Wolfram Alpha. But if you were to plug this in, you would get negative 55 and 11 over 24. So negative 55 and 11 over 24. Now, because it's area, you can't have a negative area. So my area, I'm just now going to times this by negative 1. I now have 55 and 11 over 24. And that makes sense because even though I've got a negative, which is fine, the negative bit just tells me that it's below the x-axis. That's all it's telling me. But because we know we've got area, it must be positive. You can't have a negative area. So all I need to do is times by negative 1. Now, that was, as I said, a really quick video. I hope that was helpful. If you've got any questions, obviously, just let me know. But yeah, enjoy.